we want to be really good with knowing how to control how low you will go. I think of the game of the limbo. You know that game of the limbo where someone raises a bar over you and you're trying to walk underneath it? How low will you go? Well, we'll go as low as the variance tells us. The higher the number, the lower we will go. And the bar is set based on the successor metric, the feasible distance. So the feasible distance of the successor, in this case, is 20. And you can see we've got a topology that is representative of what's going on here, okay? So you can look back and forth. Let's say we wanted to include another route in the routing table using the unequal load balancing feature. Well, what I'm doing is if I use a variance of 2, think about it this way. If I use a variance of 2, that would mean we'd have a metric we'd be willing to go up to 40. So we'd install one additional feasible successor in our routing table with this circumstance. A variance of 2 says, yeah, I'll go up to a metric of 40. And the pathway through R2 meets that criteria very well. No problem using that. Now let's say I did something extreme and I chose a variance, something more like 3. If I chose a variance of 3, this would be different. Because now I would be willing to go up to 60. My question to you is, would we do any load balancing through R4 based on what we see here? Would we unequally load balance if I choose a variance of 3, which sets how bad we will go in terms of metric to 60, 3 times the feasible distance of the successor? Well, just because that metric is okay doesn't mean we'll use it. Because we have to be cognizant, we have to be aware that it has to be a feasible successor. And R4 is not a feasible successor because the reported distance is in fact greater than the feasible distance of the successor. So this isn't going to work for us. That won't work. So we got a problem on our hands. Got a problem on our hands. Maybe not a problem, but if we were trying to make that work and we thought it would work, it wouldn't. Now, would we go up to the even worse pathway of R5? The answer is yes, we would. If our variance were 3, yes, we would. If our variance is 2, it doesn't make the grade. So knowing that we just are looking for the ratio that is inclusive of our metric, and secondly, we are not even a candidate for this if we are not a feasible successor. Those 2 criteria are what is going to take to master a command with really only one argument, the variance command. So it is a straightforward to type in command, but there's a lot of behind the scenes that we should really have mastery of before we even think about deploying this in the real world.